Right, hi Joanna. This is question 5 of the non-calculator paper. I had to redo it because I realised I'd just gone through the whole of the exam question tomorrow, so, but this is the example you've got. So what we're looking for the extrema of this function 2x cubed minus 3x squared plus 4. And the first thing I've done is I've differentiated it. So times by the power, take 1 off the power. So I've got the differential of 6x squared minus 6x. At the extrema, at a turning point, at a stationary point, the gradient is going to equal 0 because you get to that curve and it equals 0. And I'll just try and draw that. Hang on. Okay, so at turning points, the gradient is 0. So if that's true, that means that the differential of the function must equal 0. F dash x must equal 0, because that's what the differential gives us. It gives us a rule to find the gradient of the function. If that's true, then because our particular differential is 6x squared minus 6x, we put that equal to 0, and we're trying to find the values of x that make that true. Because they're both times by 6, I've just divided through everything by 6, so I'm left with x squared minus x equals 0. I've factorised it. X brackets x minus 1 equals 0, and that gives me two values for x. When x is 1, that will make the bracket 0, and so therefore the whole thing will be 0, or if x is 0, the whole thing's 0. So I've got those two values of x, but I need the coordinates of the extrema, so I need to go and find the y values. So I'm going to go back to the original function, and I'm going to put the two values of x that I found into the original function. So I'm going to put 0 in there. 0 cubed is nothing, times 2 is nothing, minus 3 lots of nothing, still nothing, plus 4. So when x is 0, y is going to be 4. And I've got my first coordinate. Okay, when x is 0, y is 4. Then I do the same for 1, put that in, get a value of 3, and that gives me a second coordinate, 1, 3. Now I've just very roughly sketched those onto a graph. 0, 4, 1, 3 would be about in those places. I'm going to show you a more formal way of finding out whether they're maximum or minimum next year, but for now we can just look at those points. We know that the turning points are there, and they're the only turning points for this function. So therefore, if the graph's got a turn at those 2 points, the only way it can go is like this. It wouldn't make sense for it to be the other way, because if it was turning at 0.4, if 0.4 was actually a minimum, then it would have to turn again. But it doesn't, because there's no turning point up here. It makes sense, so it must be this way around. So the 0.4 must be at maximum, and the other one is a minimum. And that's it. Okay, so differentiate, put it equal to 0, solve it, find the values of x. It's normally a quadratic, so you can use the formula or factorise it. Put those values of x back into the original function to find the values of y that go with it. That gives you the coordinates. Stick them on a graph and then see which one's going to be maximum and which one's going to be minimum. And that's it for that question. Okay, let me know if there's a problem with it.